All right, let's look at our first example, and we will see what kind of difficulties we might encounter when we are trying to find all local max and local min or saddle points of a given function. And of course, this given function over here is specially designed, so our algebra is not going to be too complicated. We just need to be very careful. We have x to the fourth plus y to the fourth and minus 4xy and plus 1. So let's just first find the candidates. So these are candidates for local max, min, and also for saddle as well. Okay. Really, these are called critical values, right? We're going to find critical values. Okay. And then what should we do? We take the partial derivative. Partial derivative with respect to x is 4x cubed and minus 4y. Okay. And partial derivative with respect to y is going to be 4y cubed and minus 4x. Okay. So now let's try to solve this pair, because when we try to get the critical values, we need to get actually find x, y. And we have two equations. 4x cubed minus 4y is equal to 0, and 4y cubed minus 4x is equal to 0. The method we use is always substitution method, especially when we have only two equations. 4 is a constant, so we can factor it out. So what we have is that x cubed minus y is equal to 0, and y cubed minus x is equal to 0. We can already see 0, 0 is a solution, but we want to get all solutions, so we need to be very careful. Let's call this one 1 and this one 2. It doesn't matter which one you start with. You can start from 2. You can say x is going to be y cubed, right? And then we're going to plug into 1. Plug into 1, then we have y cubed and cubed minus y is equal to 0. And that will give us y to the 9th minus y is equal to 0. And when we solve for solutions, we always factor. So this is y to the 8th minus 1, and it's equal to 0. And then we see three solutions over here. Y is equal to 0 is one solution. Y to the 8th minus 1, this one over here equal to 0 is another one. And some of us can easily see that that means y is equal to plus minus 1, right? You may wonder why, because you have 8th. You can always factor y to the 8th minus 1 is y to the 4th minus 1 times y to the 4th plus 1, okay? And then you have y squared minus 1 and y squared plus 1 and y to the 4th plus 1, right? And you can keep going, y minus 1 and y plus 1 and y squared plus 1 and y to the 4th plus 1. So you have these two solutions because y squared plus 1 is bigger than 0, y to the 4th plus 1 is also bigger than 0. Okay, so once we have y, we plug back and we get x. So we have y is equal to 0, x is equal to 0, y is equal to 1, x is equal to 1, y is equal to -1, and x is equal to -1. So we have three candidates. So we have three candidates, right? And we have 0, 0, 1, 1, -1, -1. Now we need to calculate d and also double derivative. Let's see if we can actually fit over here. Fxx is going to be 12x squared. And we see, except at 0, this is going to be positive. Fyy, and that's 12y squared, right? And then what is fxy? And that's going to be exactly -4, right? So now let's calculate d. d is equal to 144 because 12 squared, x squared y squared, right? And then minus negative 4 squared is negative 16. Okay, so now we have the conclusion. We know at this point 1, 1, negative 1, negative 1, we have fxx bigger than 0. And d is also bigger than 0 because 144 minus 16 is bigger than 0. So these 2 points, remember positive, positive is local minimum. So we have 2 local means over here. Okay. Now how about the other point at 0, 0, and then we have d is equal to negative 16 less than 0. This must be a saddle. Okay, and that's the end of the story. Okay, let's again pause, and then we will continue with an application of finding actually absolute maximum and absolute minimum.